Hi class, so today we're going to be discussing calculations using molar mass. So molar mass of an element is one of the most useful conversions. We are able to go from moles to grams and grams to moles with this, and you will do this a lot. So basically the unit for molar mass is grams per mole. So we write it with whatever the unit, whatever the compound is, and it is, or element, and it's grams per mole. We don't necessarily always write the 1 on it. For now we are, but you can leave it without the 1 on the bottom because it's known that this means 1 mole of a substance. So molar mass conversions are ratios. I look at them more as ratios or fractions. I mean, it is written from the molar mass. We relate grams and moles of an element or compound. So for instance, if we look at methane here, methane is CH4, and 1 mole of methane is 16.05 grams of methane. So this is where the mole, and there's the grams. Now, for those of you who still may be struggling with this, I gave you an example of how the 16.05 came to be. We have 1 mole of carbon, which is 12.01 grams, 4 moles of hydrogen, which you multiply 4 times 1.01, and that gives us 16.05. So that's where this information came from. You can use 1 mole over, so you can write the 1 or leave it off, but you can use it as a conversion factor, and you can flip this with the way that you need to use it. So let's do that. A box of table salt contains 737 grams of sodium chloride. How many moles of sodium chloride in the box? So we need to go from grams to moles, and the only way you can do that is with molar mass. So what are we given? We're given 735 grams. We want the moles. We do not want the grams. And we're going to use the molar mass as the stepping stone to get to the other unit. So here, first thing, we have to determine the molar mass of sodium. So it's 1 times 22.99 plus 1 times 35.45. And that gives us a total of 58.44 grams per mole. So this one doesn't have the 1 written here, and that's exactly what it means. It's grams per mole of sodium chloride. Now we can use this as a conversion factor, and even in the conversion factors, you don't have to use the 1 if you don't want to. It's just known that that's what it means. Set up a problem to convert from grams to moles. So where the problem is giving us 737 grams, so we set this up where the grams cancel out, 1 mole is on top, and this provides us with 12.6 moles of sodium chloride. A sample of water has a mass of 59.8 grams. How many moles of water are in the sample? So the first thing is we're given is 58.9 grams of water, and we want moles of water, and we're going to need molar mass. So in order to get from grams to moles or moles to grams, it always is with molar mass. So, and that's grams over mole. Write a plan to convert. So we have grams, we need the molar mass, and that's going to get us to moles. So let's determine the molar mass first. So we have 2 hydrogens. So it's 2 times 1.01 plus 1 times 16. So our molar mass of water is 18.0 grams per mole. Now we can set that up as a conversion factor, and we can solve the problem now. So 59.8 grams, we're using grams. So grams has got to be on the bottom because it's got to cancel out. And 1 mole is on top, and this gives us 3.32 moles of water. And here is a map that should help you. Let me go through this a little bit. So we have mass, moles, and particles. If you have mass and you need to get to particles, which is atoms, ions, molecules, you have to use moles. And the only way you can do that is with molar mass, and vice versa. So if you want to go to moles to grams, you have to get to molar mass first. So let's start with this first one. We have grams of an element. We need the molar mass of that element, and that'll get us the moles because the grams will cancel out. Now we want to go to atoms or ions. We will have to use 1 mole. 1 mole is always equivalent to 6.02 times 10 to the 23rd. And we use Avogadro's number, and the moles will cancel out and give us ions or atoms or molecules. Now, we have grams of a compound. So this is an element. It's the same thing. We figure out the molar mass of the compound. We use the moles of the compound. The grams will cancel out. And now we use Avogadro's number, and that will get us to specifically such as maybe we want either the Avogadro's number of oxygen atoms in a molecule, in the compound. And that's what we can use for this for. Formula subscripts, these are just the subscripts of how many. So if hydrogen has 4 hydrogens, then 4 moles of hydrogen are in that compound. That's what these mean, is how many. So if oxygen is 2, then you have to make sure you account for those 2 that's written as a subscript on here. So here's just a little map that will help you. If you want to go from mass to moles, you need to use the molar mass. If you want to go from moles to particles of whatever these are, atoms, ions, molecules, you have to use Avogadro's number, and vice versa. If you're working back this way, you have to do the same thing. So hopefully this makes sense. Thank you.